Good morning to our lecturer, Mr. Cheng. We are Group 11 and our topic is Smart Refrigerator. My name is Ko Chung Hong and I will present the study background of the smart fridge. Nowadays, refrigerator has grown to become the most essential food storage technique in developed countries. In June 2000, LG had introduced the first smart fridge, which added a lot of features compared to the traditional fridge. Not only alert when user forgot to close the fridge door like the traditional fridge, but it also able to create grocery lists, so change the temperature remotely by using the apps, and also access to the online recipe based on the ingredient left in the fridge. However, in this e-commerce era, smart fridge still have a huge space to improve. For example, collaboration with supermarkets. By doing this, users are able to buy the desired item through the apps, and also the brought item will deliver to the user's address from the nearest market. This will not only benefit to users, but also to supermarket. Supermarkets able to know what is insufficient in the local regions and can restock immediately so that they can supply to users. That's all for the study background part, and I'll pass it to my another teammate. Thank you.
Good morning, sir. I'm Liao Wing, and now I'll start presenting the problem statement part. First, let's talk about the problem of old-fashioned refrigerator. Of course, the function of fridge is to keep everything in low temperature to last longer or cool down ingredients or food. But people may forget to check on their fridge about the stock conditions such as freshness or quantity or ingredients for dinner. In this case, people will face trouble when they are in the middle of cooking. In order to refill stock, consumers need to manually approach to nearby supermarkets or grocery stores, and this is going to waste extra time and may ruin the consumer's plan of that moment. About the solution, image recognition is one of the ways to overcome the problem. A camera is set inside the fridge and it will do the image recognition job to monitor the quantity of items in the fridge. After the camera checks on the condition of fridge, system should check on those items which are not enough or in low quantity condition and send a notification to remind consumer. To make it more convenient for users to restock their refrigerator, the system will notify nearby supermarket about the order done by consumer after the remind and provide a delivery service based on the order to consumer's location. Next, I'll briefly talk about the flow of solution architecture diagram. First, the camera or sensor fetch the image inside the fridge and send the image to AWS IoT core. IoT core that connected to the device will send the image and user identification user ID to Amazon S3. After that, a Lambda function will retrieve item image and user ID from Amazon S3 bucket. For retrieving part of item image, the Lambda will call the AWS recognition to perform image detection, then only the result will be passed back to the Lambda function. The getOrder Lambda function is linked to MySQL database and use the user ID to retrieve user's mobile device details. After grabbing the mobile device detail, a notification will send to user via SNS service about the insufficient items detected. A confirmation placing order request will also be sent to customer link to an API gateway. Once customer confirm and place the order, the record of that order will be stored in another Lambda function, and it will also be stored in the MySQL database. Finally, the Lambda function will send a notification to supermarket and the order is successfully placed. Data visualization is also available through AWS QuickSight.
My name is Chiu Chang-yu. I would like to present the tool and AWS feature used by our assignment. So first is the AWS IoT core. We have used the AWS IoT core that we will retrieve the image and user ID from the IoT sensor that we had set in the smart fridge, and we have set the rules that the user ID that we get from the IoT sensor will send to the Amazon S3 bucket. The bucket is a place that store the user ID and the image that we store retrieved by the IoT core. And the Amazon S3 bucket that usually will can be provide the data to other functions like the AWS recognition. So we use the Amazon recognition to recognize the data from the image in the smart fish. That the smart fish, the image from the S3 bucket that we can use to detect the data like the apple or the banana. The result can be output that it show that the image is the particular food. That every data that we put, it will always learning and we will improve the accuracy of the recognize. So, and we use the Amazon API gateway to perform the HTTP request that we will order the thing for the supermarket. The device will publish the gateway will publish the data to the marketplace that it will status the order that we have indicated before at the device. So the AWS Lambda is the computer service platform. It can use by many cloud service. Then how to it works that the AWS Lambda, it will trigger it automatically when the based on the event. The code in the AWS Lambda will trigger when like the organization have do some events. So the Amazon SNS is the function that it can send the information to the user through the mobile device, email, or the SMS. So for the Amazon QuickSight, it used to visualize the data from the Amazon RDS. The Amazon RDS have a relationship database that it will store all the data like the order ID, user ID, and the content to the like a database that used to MySQL language to retrieve it and retrieve it. Then this data will visualize in the QuickSight that we can do a table or a chart that can see the order ID or the user ID. So for the demo part, I would like to present about how we save the JSON data to the fish detail. That basically we run the code that in the JavaScript file. Then when the code is published to MQTT device test client, this data we will save in. We have set the rules to save the data into the fish detail in the Amazon S3 bucket. And for the upload from fish function, we have the fish camera that we have directly connect with to the access ID and the secret of the Amazon F3. And when we run the code, it will upload the Apple image to the data here. So this is the demo that from the AWS IoT Core.
Good evening, sir. So my name is Leong Wai Chun. This part I'm going to be demoing after the information has been uploaded from the smart refrigerator. The information including the the smart fridge details and the image that captured from the smart fridge. The parts that I'm going to be presenting is the S3 bucket, the AWS recognition, the AWS Lambda, the fridge object detection function, and AWS log watch, fridge object detection function, the Lambda function logs. Okay, let's dive into the AWS part. So this is the AWS recognition. This is the part that I've trained the model for it, the fridge object detection model. And before we want to do the training, we want to build our dataset first. So this is the part where we build our dataset. Over here I have two labels. One is a carrot label, another is a tomato label. So over here, if you want to label everything else, you need to go to the smart labeling and then select an image, draw a bounding box. And over here you click on the tomato or carrot. If this is a tomato, you just click on this and drag it over here to do the labeling. So after everything done, this is the model that I've built. So over here, this is the model, some of the evaluation result from the model. And then if you want to start the model before diving into the Lambda part to execute, to perform the detection part, right? You need to use this one there. Use model. It is an Amazon resource name, ARN. So to start the model, you need to use this one. It is AWS CLI command. Copy this command and write it in the bash shell or in the PowerShell. They have the AWS command over there. Okay, so over here, this is the S3 bucket. There's a model training, and then the smart fridge, when it uploads the image right from the AWS IoT core part, it will store the image into the fruit veg bucket under the upload from fridge this directory. So inside here, this is the images that's been uploaded from the smart refrigerator. And for the smart refrigerator details, right, it will be stored in this bucket. Fridge details. This is the part that we will store it. It's stored in a JSON object. That pattern. So over here, this is the Lambda part. So the first part, this function will perform the Amazon recognition, AWS recognition, using the custom label to detect. So over here, this initializer to include all the project ARN, the model, the ARN, and all those other features they need. And then there's a confidence level 95. The first thing we need to do is start the label, start the detection. So when perform detection, it will return the label over here. And then over here, it will calculate the labels, how many labels are found inside there. Like inside the picture, there's 2 tomato and 1 carrot. It will show 2 and 1. Over here, this is the part that perform the counting. And here you will print the result. And this part will get the user ID from the S3 bucket, the part over here. You will get the details from here, and then get it and save it into the fridge info. So this one, there's a part you will get the user ID from the fridge info. And then this part will update the fridge object numbers into the database. So let's make an example just like just now. The one you have 2 tomato and 1 carrot, right? It will upload the result, update the result inside the database under this fridge item table, find the username, user ID, and update the quantity of it in there. So after performing this one, and then it will retrieve the ARN based on the user ID. So the ARN will be the SNS ARN. So there's the SNS ARN. Each user, they will have their own unique topic. So let's make an example. For U00001 smart refrigerator user, it will have 1 SNS topic. So this one will be the email that has been subscribed under this smart refrigerator, the user's emails. Okay, so go back to here, the Lambda part. After you get the ARN ready, then you perform to complete send to SNS as destination. It will send to the destination if the fridge object, right, is not enough, less than 3. So if the item like tomato or carrot is less than 3, which means that the user need to refill the item right inside the fridge. So this part will perform the email sending. It will send the email to the user. So I have run it before, so it's going to take some time. So I've created everything else, and over here this is a log. Where's the log? Refresh it. So there's the latest log. We can check it over here after the AWS Lambda has been executed. Over here you can see that there's a part, start the custom label detection, okay, the key bucket, start prediction, after prediction end, and then it will show that inside the fridge there's 2 tomato and 1 carrot only. So S3 bucket retrieve, this is the user ID of the smart refrigerator, and then fridge item updated inside the database, and this is the ARN of the smart refrigerator user U00001. So there's a message URL, and then this part, which means that the email has been sent successfully to the user because the user doesn't have enough of item, right? Tomato is below than 3, so the user will be asked if the user need to be refilled, need to fill up the refrigerator for the tomato item. Over here, go to the email part. So this is the part that it will show. This one, not this one. This one, yeah, this is the one. Okay, so it will show us that the item tomato is, the quantity is 2. So in order to refill the item, right, the user need to click on the link in order to refill it. So this is the link that will be clicked. If the user click on the link, it will redirect the user to the mobile site to place the order. So this is the mobile site. Okay, so that's all for my video. Thanks, lecturer. So I will pass it to another presenter to present another part. Thank you.
Thank you, Wai Chun. And the next will be the demonstration for placing new order and also display of the order info. My name is Ko Chung Hong, and I will continue the presentation. The presenting parts include AWS Relational Database Service and also the tables to store those information, and also AWS Lambda for new order and get order info, AWS API Gateway, and finally I will do a simple demonstration on mobile site. So the first one will be RDS. This is the RDS created in the AWS, and we have to remember the endpoint, username, and password for the connection with the MySQL workbench. Then I will introduce the tables inside it. First will be the user, which is used to record the user's information like first name, last name, phone, email, and address. And also the ARN will also record inside it. Then will be the fridge item. Here we will record all the information or all the items included in the fridge for the different users. And later on will be items to buy. Here we record all the items which user desired to buy. And after that will be supermarket. Supermarket will record all the information for the different market. And then will be orders. Orders will record the user ID, market ID for the order, and also the total price. Then will be item ordered. Here we'll record all the item which user order in the order ID. After introduction of the RDS and the tables, the next will be the Lambda function. The first function is the new order, and from the code we can see the first one is the import myserver, and after that is the configuration values like endpoint, username, password, and also database name. After that is the connection to establish the connection between MySQL, Workbench, and also the AWS. The first method is to generate the order ID, and the second one is to create order. The last one is the main method. Here to collect the user ID, item number, market ID, and also item name and quantity from the API Gateway link. And finally, it will return an order ID, the new generated order ID. The another Lambda function will be get order info. This function basically will return everything by using the order ID. So the first one will be get order from the user API, and after that it will create a response body which include everything about the order, for example created date, item order, and also username, user information, and also market information. and finally it will return it to users. After Lambda function, I will introduce about the API gateway for our project. This is the API gateway we created for new order and also get order info. To test whether the Lambda function is work or not, we have to go to stage and we choose the get order info stage and click the get. We can get the link here and we open it in the new page. And after that, at here we have to do the same thing which the API get will retrieve, which is order ID. So at here, for example, we will take 0000001, and here we will display all the information like order ID, username, user first name, and also market information. And also here we will display all the items inside the order. After that, we can do the same thing to test the new order function. So use the same link, and after that paste the input. In the input, we have to include the user ID, market ID, item number, which is to include the type of item inside the order. At here we have two items, which is tomato and also orange. And here included the item 1 and also item 2, and also the item 1 quantity and so item 2 quantity. And after that, it will return order ID, which is newly generated one. So we can check it in the MySQL workbench. After that, to check that the order is successfully generated, we have to check the MySQL workbench. So from the orders table, you can see that there is the new order ID, which is 000010, and also in the item order, there is 000010 is having two items, which is tomato and orange, and the quantity is identical to the link one. The last part will be the demonstration of the mobile site. This is the code, and the URL is the API gateway's link we tested before, and the complete string is the combination of all the important information, for example, market ID, user ID, the item name, and also its quantity. After that, when everything is combined into a URL variable, then it will be fetched and the response will be received. And we can see that there will be the new generated order ID will be appear. The link above is coming from the email, which is to alert the user to replenish the stock. And here we record the user information, user ID. After that is the item number to replenish, and after that is the two items. So firstly, we have to choose a supermarket. And after that, here is recorded the tomato and carrot, which is the what user needed. So here I will enter 15, and here I will enter 3. Then here can add the new item. For example, I want an orange, and the quantity will be 1. Then after that, confirm. So after that, we can see that here have a succeed information, and here is the new generated ID for this order. So let's check to the workbench, and we can see that here have the latest order ID, which is 00000011, and yeah. Then after that, in the item order, then here also have these 3 items. Then we can know that this order is successfully generated. That's all for my presentation. Thank you.
So for the quick site function, we have retrieved the data from the Amazon RDS that it contains the order ID, user ID, and the other data that we order from the market. That we can see the user order order the order ID and the status that have been delivered. So we visualize the data. We can see that the okay we can see that the data by we drag, and we can see that the value, the total number that we ordered by count the value there, and we can see the status by grouping it by the user ID that for the order ID. And we can see that the user ID have 3 order ID that already complete one of the order and still have the 2 order at processing it, and the user ID 2 that only have 1 deliverer. So this all for my part for the quick start. Thank you.